Hey, welcome back. I'm gonna try something a bit different with this video. This is mostly the type of stuff I do in the shop that I don't usually make videos about, because I think it's probably pretty niche content and not that interesting to most viewers, but I'm just gonna give it a try. This is basically a collection of all the small and large improvements and modifications that I've done to my lathe, and just a bit of general lathe and shop talk. Since I get this question all the time, this lathe model is a Zeek SC10, and as you probably guessed, that's a Chinese manufacturer. I'm not gonna get into the whole topic of buying a new Chinese machine compared to buying a used industrial machine, because it's just a huge can of worms and everybody has their own opinion. But I'll just say I don't regret buying this thing, and I think these types of machines are usually a good deal as long as you have the right expectations. This lathe has done everything I asked of it so far. It has decent power, it's accurate, and has the features that I wanted. But especially with these import machines, there's always some room for improvement. So let's take a look at some of the changes that I've made. One of my first changes was to get rid of this control panel. I didn't like the fact that it's made of plastic and it had these touch type buttons, which are kind of hard to tell apart when you're not looking at them. So I switched that for an aluminum plate and installed some proper switches. There's one more early mod that I didn't film, and that is a modified handwheel for the carriage. In its original state, the gear ratio between the handwheel and the carriage was just way too high for my taste, meaning you could move the carriage pretty fast, but it was hard to position it with any kind of accuracy, because even a small movement on the wheel would translate into a relatively big movement on the carriage. So my solution was to build this little gearbox, which achieves a 1:4 gear reduction. So now I have to do 4 rotations to travel the same distance, and that makes it much easier to position it in small increments. The next mod is something I'm actually going to revisit in this video. Quite some time ago I improvised this digital readout for the tailstock using one of those cheapo digital calipers, and it did work out okay overall and also turned out to be pretty useful, but I was never happy with this particular implementation because it's not very elegant and it also has a tendency to collide with the Toolpost. To do it properly this time I bought this DRO kit on eBay, and this is basically the same thing as the caliper, except this is actually supposed to be installed on a machine and comes with a separate display. To install this I need to drill some more holes into the tailstock, and since I hate using handheld drills for this type of stuff, the whole thing is going on the mill. Then I just made this simple mounting plate, and the next step is to install this and also make a counterpart that attaches to the quill. This piece will connect the quill to the moving part of the scale. And at one point while I was making this I thought I had messed up the part and had to scrap it, but then I was able to salvage it, so anyway, this is how it ended up looking. Now the display can be attached wherever I want using magnets, and overall I think this is a much cleaner solution now, and most importantly it doesn't interfere with anything. Next up is some tool storage. I used to keep the tool holders under the table here, but it's a bit inconvenient, so I decided to whip up a quick tool shelf from some scraps I had laying around. Often when I spontaneously build stuff like this, it's shaped largely by what kind of materials I happen to have around the shop at the time. So this might not end up being the best possible solution. Even though I built some things in an overly elaborate way, I'm also often pretty pragmatic about other builds and just want stuff done quickly and good enough so that I can move on to something more interesting, and this was definitely one of those cases. The extra storage for the chuck keys here wasn't even something I planned on originally, but it turned out to be very useful in addition to storing the tool holders. And now all the most frequently used stuff has a home and it's easy to reach. The next mod is a bit unnecessary and more of a personal satisfaction build. I've always been bothered by the fact that the headstock has these plastic covers on top. Functionally, there's nothing wrong with these, but something about plastic parts on a lathe just feels wrong to me, so I decided to switch these for steel plates. I think these are something like 10 millimeters thick, so pretty beefy for that purpose. And now you can actually drop some heavy work pieces on here without a second thought. I chose to just leave the mill scale on the plates because I think it's actually kind of cool looking in this case. And this stuff is super hard, it doesn't rust, and it's not a bad surface finish. And a nice side effect is that magnetic tool holders can now also be used here. Now it's time for the biggest modification so far, and to explain it, I'm just going to show you what used to happen when I tried to do parting or cut-off operations on this lathe. Just in case you've never used a lathe, this is not how you want it to sound like. Okay, so maybe that was just a crappy parting tool, so let's try another one which has never been in use, so it should cut okay. And there we go again. You can actually see how everything on the lathe is starting to shake and vibrate. Alright, so maybe the tool holder was the problem. So here we got another tool holder which is specifically meant to hold parting tools, and also a brand new parting blade which has also been freshly sharpened. Seems to work a bit better in the beginning, but nope. This is unfortunately a pretty common problem on this type of lathe or smaller lathes in general. The problem here is the overall rigidity, which really becomes an issue with parting, since it's a pretty brutal operation for any lathe, and it can really highlight those issues. The problem isn't really with the lathe itself, but with its weakest link, which is very often the top slide. The top slide gives you an additional degree of movement on a lathe, which is most often used for cutting tapers. Apart from being the flimsiest thing between the actual tool and the carriage, this is also usually the part with the lowest build quality on these import lathes, and with tolerances not being that great, that means even when you lock it down, there's just too many ways this can still slightly shake around. which makes the whole setup less rigid, and that creates vibrations and chatter and all the problems you just saw. So one common solution for that is to simply ditch the entire top slide and replace it with a solid tool post. That way you lose the ability to cut tapers, but in exchange you get a much more rigid setup, and you can always go back to the top slide if and when you actually need it. So that's what I'm gonna build next. I'm cutting these angles because I'm going for shape here that actually leans over the cross slide a bit, which gives me a bit more clearance when I want to work on large diameter parts. I think it would be best to make this from cast iron, but I'm still a cheapskate and that stuff is expensive and hard to find, so I'm once again using the cheapest possible metal I can get my hands on, which is the hot rolled mild steel. Not very fancy, but a solid chunk of that should still do the job. Alright, so let's give this a try and see if anything changed. I didn't expect much, so I was shocked by how big the difference is. Having changed nothing about the setup except for that tool post, I could instantly start parting off 40mm of steel without any issues. I even got a bit cocky here, and instead of hand feeding in this shot, I'm actually power feeding into the cut, which is something I would not have dared to even try before, and the lathe simply walks into this cut like it's nothing. So just for kicks, let's also try some aluminum. I'm running this with the power feed again, and unsurprisingly this also works perfectly. And with that I can say I'm super happy with this modification, and if you've ever had problems with chatter on your lathe, I would definitely recommend you give this a try. Next up are some wake covers. I used to have this rubber flap attached here, and while that did help a little bit, there's still always a lot of mess on the ways. So I'm gonna make some ugly but functional covers that will hopefully make the cleanup much easier and also reduce wear on the ways. Rubber is most likely not the best material for this, but I happen to have this large roll of fairly thin rubber mat in the shop, and I'll just use that for now and see if it works out. The idea is to sandwich the rubber between the plate and these aluminum strips using rivets. And then this whole thing will just attach between the cross slide and the tool post. It would be better to do a cutout here so the tool post sits directly on the cross slide, but just like with the rubber, I decided to just go with the simplest solution at first and see if I notice any problems, and then I can always make things more complicated later. Thanks to these flaps being relatively thin and flexible, they actually do a pretty good job of just kind of rolling themselves up and out of the way. At the point of making this video, I have already used this setup for a few weeks, and they're actually less annoying than I would have expected. I can honestly say it's pretty rare for these covers to really interfere with the work. So while I'll be the first to admit that this isn't exactly a nice looking solution, it was super easy to make, it works great, and I haven't had to clean chips off the ways even once since I installed the covers. Last mod for today will be a chip shield. Sometimes the lathe likes to shoot a stream of chips straight in your face, and even with safety glasses that gets old pretty fast, and it also creates a huge mess, so for those moments you want something to deflect those chips. To hopefully contain that a little bit, I want to make a decently sized shield, and for that I'm going to use some of this stuff. That's a sheet of polycarbonate, which is the same stuff they make riot shields out of because it's super tough and transparent. At this point I want to take a quick break for a little update. You might notice the shop looks a bit different in this shot, and that's because during filming all this I actually moved out of the makeshift workshop that I've been working in for the past 2 years. I'm not sure it really came across in the videos, but I was working in this wooden shed thing here, which was inside of an old shared industrial hall. The nice thing is that it was cheap, but everything there was very improvised. I had a roof made of bubble wrap, it was cold as hell in winter, the floor was made of these pave stones from hell, and plants were growing into my shop. So needless to say, I'm glad I finally found a place to set up a proper shop again, which looks really sleek and clean, and most importantly it has luxuries like heat and 3-phase power and water, and I'll hopefully stay there for a while, and I plan to show you the new shop in some more detail when I finally do a shop tour, but for now I'm just showing you this to explain why the videos look different. Since I have more space in the new shop, I could finally fit a table saw in there again. And that comes in handy because you can cut a lot of materials with these other than wood. For example, this stuff. Another cool thing about polycarbonate is that you can bend it. So I'm whipping out my metal brake here, which seems to get heavier every time I do that. I've never actually tried this before. I think I read somewhere that you can even cold bend this, but it's a pretty tough material, and it turned out that even after heating it up quite a bit, it didn't seem to soften up that much. So eventually I just went for it, and it did put up a bit of a fight, but the bend turned out pretty nice. This is what I used as a shield so far. It's one of those useless things they put on drill presses to avoid lawsuits and that everyone removes right away. And it's also way too small for this purpose, but it already has this handy attachment piece, so I'll just steal that and use it from my new shield. And as always, when I'm not sure how I want to mount something, I just drill a bunch of useless holes so I can change my mind later. And here's that satisfying moment you've been waiting for. Unfortunately, this thing is never gonna look this clean again. To make use of this, I decided to just put it into one of these flexible magnetic tool arms, which usually hold dial indicators. It's not very heavy, so this thing is strong enough to hold it securely in place. Thanks to the new Toolpost having all these large flat surfaces, this can now be attached in a number of ways, and then you can set it to a lot of different positions depending on what's needed. And if I don't want it moving around with the carriage, I can now also attach it to the headstock and have it sit over the chuck. And what's also nice is I can also use this for the milling machine or pretty much any other machine, because you can attach it to any magnetic surface. That's all for today. I have a feeling this won't be the last mods I've done to this thing, and hopefully you could get some useful information out of this video. I know I'm like the slowest YouTuber ever when it comes to releasing new videos, but I got some cool projects planned for this year, and I don't want to promise too much, but with the new shop situation, you can hopefully look forward to some more output from me. And if you want to see what I'm up to in between videos, you can always check out my Instagram. So until then, thanks for watching and see you next time. Or not, it's up to you.